All right, this is BCA-101, and this was Tuesday, and this is Thanksgiving week, so we don't have class on Thursday. So we reviewed. Again, we talked about data, and a term used a lot nowadays, big data. We're looking at for the students to talk about. We talked about the amount of information gets smaller and smaller as we communicate the different levels of management. It doesn't have to follow that exactly, but we have some level what we call management. We have the workforce down here, we have data, and I think we talked a little bit about transaction, tactical, strategic information. So it's trying to understand which data should go to which place, and then having software do that for us. And in doing that, that allows us to make decisions. Structured decisions can often be made by the computer itself. Semi-structured information can help us, and information can help us make non-structured decisions. But the structured decisions are decisions that the computer can make by itself. Like if it knows when milk gets to this level, it orders it from this company. That can be built into the information system. All right, so I kind of beat that to death, but I want to review it again. How we develop these. Typically, you start out, you have to know what you're trying to do. We can call it a problem, you can call it an opportunity, you can call it a challenge, you could say we have an issue, we have some reason that we know there's a better way to do something. Either technology is changing, allows us to do that, or whatever. The analysis stage, you have to understand what this is and all the items tied with it. Once you understand it, then you can design a solution. And we talked about flowcharts and pseudocode and all the different things you might use to design it. You might use this if you're going to write your own code, but you design it. The blueprints of how the information system will work. You've got to have a hold on this. If the information system is life and death, like you're writing a new information system for air traffic control or to manage the subways in Washington, these steps are so critical. You can't start designing it, actually developing it, until you know exactly what you need and what will happen in what situations. I give an example. The healthcare website probably didn't do as good a job as it should have on this. They developed it, and then they have problems. All right, then we go to the development. You actually write the code, buy the equipment, and you just put everything together. Implement it. You have to be careful on how you might implement it. You should have developed some test data up here. The analysis stage also would have done a, we could call it a cost benefit analysis. We're going to spend this much money, and these are the benefits we're going to have. Okay? So, we do that all the time. Sometimes we do a good job of that, sometimes we don't. Okay? Are you going to buy the ice cream cone or not? The benefit is it'll taste good. You won't be hungry anymore. I don't know. So, you go through all that. You figure out how you're going to test it to make that. And so, in development, you're actually starting to test it during development, you're creating it, and then when you're going to implement it, you could put it in one area, a pilot, like implement it in one branch of your business, whatever you're doing, maybe a new type of payroll or something, and try it there. You could phase it in, put in one part of it, then another, and work that in. Direct cutover, you quit the way you were doing it, new system. Pretty dangerous in some cases, but in other cases it's the only way you can do it. Some people run both systems for a while. They run the new one and they run the old one, and then they just match them up. A little more work or a lot more work depending. So we have those things. You could run a pilot, phase it in, direct cutover, or parallel. Once it's up, this is crucial. You better evaluate. You have to make sure this is working. that you're getting the benefits out of it. Because some systems, even though after people invest huge amount of money into them, the system works so poorly that they need to scrap it and not use it. That's a fact, okay? Then evaluation and maintenance. You are going to find little things wrong, so you'll need a fix, maybe an update or a patch. How you develop those, you come back up and you say, okay, we've got a problem. This part of the system doesn't seem to be working efficiently or whatever. Okay, we analyze that. What's the issues? We design a solution. We develop it, maybe writing new code or fixing the code. Then we implement the patch. And then we check again, make sure it's working. All right. Now in here, I'm going to talk a little bit more here in a minute about the development. Artificial intelligence, we will, I'll mention that, and then I'll go to programming. I kind of talked about this afterwards, but we can talk about it right now. One of the last things in the course is we talk briefly about artificial intelligence. Robotics, huge. You know, we have robots can do all kinds of things, anywhere from vacuuming a house to driving a car to a ton of it used in manufacturing. We use robots in dangerous situations like looking for landmines in Iraq maybe, or robots in paint booths, or robots to clean up nuclear waste and so forth. Robotics. It's amazing. We have robots that assist in doing surgery. We have you know, anything where there is a structured, you can program the structure, the steps of something that needs to occur, and you can teach a robot to do that and teach it well. Okay, so robotics. The next thing, we don't talk about the whole world of artificial intelligence, but I think it's good to understand what expert systems are. We just learned databases. We learned about relational databases, and you have tables, and we do queries. You query the database, get what you need, and that information flows to the right people. You can create reports. We can query the database, create a report, send that report to the right people in management or wherever they need it. And nowadays it could be anything. You know, we can, via the internet, go look up all kinds of data and get reports like on maybe the medium income of families in the United States. You can get that stuff. You can query it, get a report, and have it come right to your computer screen as long as you have access to the internet. All right? An expert system is a little different. It creates, you create a knowledge base based on rules, and then you use an inference engine to manage that knowledge base. Here's a really simplistic example. If somebody said the car doesn't start, somebody might ask them, well, when you turn the key, what kind of noise does it make? Okay, that's a little piece of knowledge. The inference engine is what's asking the question. So the inference engine asks a question, does it make any noise? And somebody says, yes, I can hear the engine turning over. Yeah, I can hear the engine making noise. Okay, so now in the knowledge base you would say, it's probably not the battery. Okay, if it's turning over plenty fast, probably not the battery. Then the next question, do you have enough gas in the car? Okay, it says it's on E, which means enough? No, maybe not. Okay, but then you go somewhere else in the knowledge base. You ask another question, the inference engine then does this. It works typically down like a tree, you know. They answer this question one way, then we go this route. And then we ask another question, then we go this route. And eventually you get in the knowledge base somewhere as to what a possible solution would be. Doctors do this all the time. The doctor has the knowledge base. They start asking you questions. Based on your answers, they work their way towards why you might not be feeling well or why you might be sick. So in a knowledge base, we have rules. And an inference engine asks the question. And they can be used for anything. You know, they can be used for anything. Maybe how to load a truck at FedEx before a route. And the truck can be loaded multiple ways and still deliver all the package, but what's the most efficient way to load the truck in order to do that? So the knowledge base would ask, what's the address on the package, or what are all the addresses on the packages? And then it would figure out the best way to put them into the truck and the best route to deliver them. So we have multiple things. We can use expert systems to help us with some non-structured or maybe semi-structured decisions. Help us do that. Okay? Mrs. Fields Cookies, she had multiple stores and had the workers in the stores always contacting her. What do we do about this? What do we do about this? So she took all of her key ideas of what to do in situations, put them in a knowledge base, created some rules, and had an inference engine that actually did it. Her husband worked for IBM. He helped her put it together. And her next big step in life was she created an expert systems business where she did that for businesses. She would take the knowledge of experts and be able to store them electronically and then allow people to access them. Like she said, if you don't sell a cookie, a certain number of cookies, within an hour, you give 2 cookies away. Okay, that's a rule. So what can we do to get the sales up? Well, how many cookies have you sold? This many. Well, you need to give a couple away so people in the mall see people eating cookies, and then they'll come and buy them. All right, on to the next slide. This is a longer than usual podcast, but I'll keep going here. If you think back, we had this arrow. This actually went to the development stage in creating an information system. All right. If you're going to manage information, you can buy software that can maybe do what you wanted to do. You might be able to buy a package that does it specifically. You can buy a package that helps you do payroll. Just buy it, do payroll. Payroll's a pretty structured decisions. You put the information in, the computer spits out the right answer. You add new tax tables every year and so forth. You might be able to buy some packages that you can change and adjust. We buy here at the college WebAdvisor, which allows students to schedule classes and look up their grades and et cetera, et cetera, et cetera. And that package is customable. You know, we're able here to customize it so you can adjust it or change it. You can buy software doing that. If you can't find a package or this is expensive, you don't have people to manage it, you can just say, is there somebody that'll actually do this for us? Okay, that'll actually do what we want done for an information system. So you just communicate with them, and so there would be some cloud service that does about anything nowadays. Okay, you can create your own. You know, big companies, small companies, any size companies sometimes create their own. They might use some very simplistic software and create their own little information system. It might be as simple as a spreadsheet to keep track of what they're doing. Or it could be as sophisticated as Walmart. Walmart creates their own information system, very sophisticated in how it manages ordering, keeping track of its vendors, and its vendors keeping track of what they're selling at Walmart, and then the logistics, getting it to their warehouses, and then from the warehouses to the stores, and et cetera, et cetera, et cetera. Why? Creating your own package typically could be a little more expensive or extremely expensive. They have good programmers and the hardware and the software and all that, and manage the WAN connections and so forth. It can be extremely expensive to have somebody create software. So why? Why create your own? There's nothing out there that does exactly what you want to do. There's nothing out there that does exactly what you want to do. In my life, so often when I've seen situations where I need some simple software to do something simple, sometimes you can't find it, so you just write some code to do what you want it to do. All right. Now, the other reason, it might give you some added value, because you might have something that none of your competitors have or nobody else has or does. And in that case, or you might do it so much better than anybody else because of the software you have, or your product is easier to buy, or it's easier to get shipped, or the communications is simpler, or the return policy works better because it's easier to do, and how you print out the return labels. And you can just go on and on how some people build a huge advantage in their company. They build that competitive edge into theirs because they create their own rather than use something everybody's using. All right, I beat that to death. So if you're going to create your own, you got to design code. You got to program. Okay? Anytime you write a program, it's the same thing. You got to have some reason. You have to understand where you're going with it. What is the program going to do? You can't tell somebody I got a problem and I want you to write some software to do it. Well, you got to specifically, you got to tell the computer what to do. The computers don't just magically come up with solutions. So then you have to have all the specifications that are going to address what you want done. And sometimes this is extremely hard because people who are helping the programmer figure this out don't understand enough about software or programming that they really don't even know what to ask for. But anyway, this is a huge mesh right here. Once you know what, then people can design the code. They can design how we're going to do it, and then we write the code. Write the code in some language. And holy smokes, we listed all kinds of them here. You can write JavaScript, which would be interpreted, Java, Object-C, PHP, Python. Oh man, there's just you couldn't name them all. Literally, just tons. There's some old school ones: Cobalt, Fortran, Pascal, assembler language. People can write very close to machine code. Anyway, you have a high level, what we call, or high level languages. This wouldn't be considered high level, but you have some language, and what you write then is the source code. It's a code, and we're going to look at a little code before the year is out. We're going to do that hour of code with code.org. You write the code using some language. So you use the syntax and you tell the computer what to do. You compile it. You can compile it in based on what operating system it's going to run on, or you can interpret it. Interpreted code would be, I don't know, an example might be a little bit like JavaScript, where the code is actually executed right, in that case probably right in the web page while the web page is being used. It's not actually compiled into an executable code. So compilers are software that converts the code into something the machine understands, and then it's considered an object code, and then from there it's linked into executable code. And you may or may not be able to see that executable code down there. I'll pull this up a little bit. There we go. So now this executable code. So you get a program like Putty. Somebody wrote the code to do Putty. They wrote some source code, I don't know, some language, maybe C++ maybe. And then they compiled it to run on Windows. And then you can go to a site and you can download it. And when you download it, it's putty.exe. The exe means it's in executable form. And that executable form will run on Windows 7. If you're going to run it on Linux, then you would have to download the one that would work on the Linux operating system. If you're going to do it on a Mac, you'd have to find one to run on the Mac's operating system. One that's already been compiled to work that way. Okay? Now, that is free. Putty.exe is free. It's really considered what they call open source. Here's where the word open source comes from. The source code is not regulated. People can go in, adjust the source code, so we can have somebody working on really cool software like Linux, or maybe a package that runs on Linux that's open source, and lots of people can go into the code, make adjustments, change it, and make it work better. So we have literally an infinite number of people trying to make the code good. And then they license that, and it's licensed in the realm of it's open source. You cannot ever claim you own the source. So you always have to make the source available to other people. Now you could change it and charge people, but you have to make what you did available to other people. It's kind of interesting. So a lot of people will take open source items and then sell the support with it. Okay, you saw the support. So software that's proprietary. Proprietary software would be like Microsoft, Adobe, and so forth. when they compile from the source to executable, you get a lease for their software, which allows you to use it. But you can't decompile it. You can't go backwards and then change the source code, because they own that. Okay, and they let you use it. You really don't buy the software. You use it. That's proprietary software in compared to open source. Open source means source code's open. Plus, a lot of people think of it as being free. And that is it. Longest podcast of the year. Oh, it's not quite it. One more thing. Well, electronic commerce, e-commerce. I can actually pull that down a little bit. E-commerce, business to business. Businesses are doing commerce with each other all the time. Customer to business. We buy stuff off of Amazon, and we do business with our banks and so forth. Customer, eBay, Craigslist, all those different things in which you can do electronic business between business. This is really huge. It's big nowadays. We do a lot of business electronically nowadays, and so you could have a whole course on that. All right. Well, that's it.